Welcome to this edition of Frontiers, and welcome to Red Rock here in Lynn, Massachusetts. We've come here to set the stage for this edition of Frontiers. Now, just imagine something as you look over my shoulder and envisage a quarter-kilometer cube of ocean water. Within that cube is a fusion fuel called deuterium, which could provide enough power that equals all of the power that could be generated by the known oil reserves in the world today. Utopian, dream, or reality? Well, enter the debate called cold fusion. That entered the pages of the newspapers of the world and the airwaves of the world when Professors Pons and Fleischmann announced that they had generated a reaction in a simple tabletop test. Well, at this point, I should introduce our guest for this show. He is Eugene Mallove. He was the former chief science writer for the Massachusetts Institute of Technology's news department. But now he's an author. His book, Fire from Ice, looks at the cold fusion debate. I'm going to leave it to you to decide whether or not it is a utopian dream or a possible reality. We're going to meet Eugene Mallove in his study in his home in New Hampshire. We start with the very first question I ask him, and that is, just what is cold fusion? Eugene Mallove.
Eugene, the good starting point is really a definition of cold fusion, so we know what we're talking about here. Let me roll that challenge out to you first.
Well, cold fusion has to be defined in comparison to hot fusion, which is the idea of mimicking the stars. The stars make nuclear energy out of very high temperatures in their core, tens of millions of degrees, in which hydrogen atoms, in effect, the central parts of hydrogen atoms, the nuclei, are banged together and they fuse and then release energy and massive radiation, and we get sunlight and starlight. Cold fusion is the process which we believe to be occurring in very special conditions in electrochemical cells that Pons and Fleischmann and others have been working with over the last numbers of years. It's a nuclear energy source, I believe, that doesn't release the kinds of damaging radiations that hot fusion releases.
Tell me a bit about the potential. It's an enormous frontier for people, isn't it? Because of its potential.
The potential for fusion energy use on Earth is indeed enormous. If we believe that the deuterium in seawater, which is only 1 out of every 7,000 hydrogen atoms of H2O in water, is deuterium, as just the way nature constructed water on this planet and elsewhere in the universe, the potential energy from fusing these atoms together and releasing energy is such that 1 cubic kilometer of ocean contains more than enough energy to exceed all the oil reserves of the planet.
And therein probably lies one of the key reasons for the intensity of the debate.
That's correct. There basically is an infinity of energy, for all practical purposes, that we can get from fusion processes using hydrogen, or a special form of hydrogen called deuterium, which is easily obtainable, essentially free from seawater in the oceans of the world.
Now, you mentioned Pons and Fleischmann. It's Stanley Pons and Martin Fleischmann, two professors who in 1989 announced that they had found the way to cold fusion, that there was indeed energy. What happened? There was such an explosion around that simple announcement. You've studied it.
There was an enormous reaction on the part of the scientific community. The first, of course, was incredulity, and I myself wondered what was going on because I didn't believe that it was possible to circumvent the process that had been engaged for the last 4 decades, that is, the process of trying to mimic the stars by making very high temperature gaseous plasmas in very complex and expensive machines. I thought that anyone who suggested that they could do it in a simple tabletop experiment, which looked like an ordinary high school chemistry experiment, certainly must be wrong or deluded or some combination thereof. But the more I got into it and the more I saw, despite the difficulties with that ensued with attempts to reproduce the experiment and questions over what it really was, I saw that there really was something there. At least that's my very strong opinion. And what happened in the world was that the scientific community reacted first with intense skepticism, but with polite skepticism. They went about their task of attempting to reproduce it. Some got it, some didn't. Those that didn't, by and large, became very outraged at the whole business and started to attack it, and became very severe opponents, and are to this day.
You found yourself really sort of right in the middle of it all, because many skeptics say that there's nothing to it whatsoever. Particularly, I'm thinking of Nature magazine, the scientific journal out of the United Kingdom. Why are you putting yourself in the middle of this?
Well, I didn't put myself in the middle. I just happened to be in the middle. I was the chief science writer at the MIT News Office in March of 1989. It's my alma mater, and I was proud to be there. I'm no longer there. But I saw the battle raging, the scientific controversy, and it appealed to me greatly as a person who was interested in science, trained in science, in fact, and a writer about science. It intrigued me that I might be able to synthesize the controversy into something of the nature of a book that people could read and understand ultimately. And I didn't know where the controversy was going to go, quite frankly. I was a skeptic of cold fusion in the beginning, but I grew more and more strongly of the opinion that there really was something there. The book evolved over time. Now, I was right there at the nexus of the people who were attacking cold fusion and those who were trying to study it and find out what it was all about.
What gives you a sense of hope that indeed there is something valid to the cold fusion theory?
The thing that gives me hope is the enormous number of laboratories around the world that have gotten positive results. There are now over 100 laboratories in the world that have various types of positive results for cold fusion, either nuclear products such as tritium or neutrons or charged particles, or helium gas coming out. And there are laboratories with very impressive power outputs per cubic centimeter of material in the cells. I can't imagine that all of these experiments, and they're all quite different experiments, and it's not all reproducing the same sort of thing. I can't imagine that they are all systematically wrong. It's not impossible that they're all wrong, but I just don't believe that. I believe the most likely explanation that fits this host of very bizarre results that do fly in the face of conventional scientific theory is that there is a new phenomenon there. And there are some excellent theories, by the way, that begin to explain what this might be. And it is a new nuclear energy source.
As you look at it, what's this saying to the scientific community in the United States?
What this is saying is you better pay attention to this, even though many of you are not paying attention to it. You think that it has been written off by a joke, because some very prestigious institutions, including MIT, including Caltech, and a number of other places, Princeton, have done experiments early on, which they thought were negative, and have then dismissed the whole thing outright, and have in fact begun to attack it, attacked it from the beginning almost. It says, go back to the data. Look at the data. Look at the data as it exists now, not as it existed in March of 1989, when it was very preliminary. Take a look at what's happening in the field of cold fusion research today. Look at, there are journals that are publishing regular articles now about cold fusion. The Journal of the American Nuclear Society, the journal Fusion Technology is publishing regularly on cold fusion. Give it a second chance, because whether you like it or not, you're going to have to deal with it.
Welcome back to this edition of Frontiers. I'm John Parrott, and my guest is Dr. Eugene Mallove, author of Fire from Ice, a book based on the debate surrounding the scientific theory of cold fusion. Dr. Eugene Mallove. Eugene, the whole debate surrounding the cold fusion issue, doesn't it highlight something much more fundamental in America's approach to science and research?
I'm not sure we can draw extended parallels from cold fusion. There are definitely lessons to be learned from cold fusion about the process of science. It's sharpened up many of those issues. But cold fusion is a very unusual event. It's unusual to have something that contentious in science. Yes, in science there have been many revolutions that prompted debates where the passions rose and so forth. This doesn't happen all that often, but it happened in this case. I think it does teach us lessons. It says that in general, you don't do science by majority rule. The majority in this case was wrong, okay, in my opinion. They missed the phenomenon. They continue to miss the phenomenon. They are continuing to ridicule it and saying it's not there, but it is there. Okay? So you can't believe the majority, you can't take the vote. Okay? It also says something about peer review. Many journals, such as Nature and Science magazine, have almost literally banned any positive cold fusion stories from appearing, and in fact have put in the most scurrilous negative stories that they could possibly find. And this says that even some of the most well-regarded scientific publications can be in error, and are capable of being in error when driven by forces that aren't necessarily scientific. That is, they're not trying to find the truth about something, they're trying to literally kill something for their other agendas.
What about the pressure in research, the ability to see something happening that you didn't expect to happen? Isn't that an essential lesson out of this, that you don't come to your research with such a locked-in, preconceived notion that you actually miss something that's flashing there?
Well, I always thought that the whole point of science was to be open-minded and be on the lookout for new things, particularly anomalies. Science is driven by anomalies. When you see something that departs from the ordinary, that's the most beautiful thing, because you want to study that, and it teaches you that there might be something else lurking there that you didn't understand before. Now, here we have, in the case of cold fusion, a very anomalous claim. That is, take heavy water in a cell, put a palladium rod in and a platinum rod in, and put some lithium carbonate salts in it, put electricity through, and at a certain period of time, you will get more power coming out of this cell than you put in electrically. And you will get tritium coming out, and you may get some low-level neutrons, and so forth and so on. The anomalous claim that more power could be coming out than is being put in is an extraordinary claim. And there are many laboratories that have that. Now, there is a refusal on the part of conventional scientists who have their blinders on to accept that that could occur. It goes against their grain, because the idea that there might be nuclear processes occurring in a simple chemical cell like that does, in fact, fly in the face of all known theory. But it doesn't mean that it's impossible.
Now, that's a key issue there, is how do you make the impossible more visible, as it were, in the mental climate that surrounds research?
The only way of dealing with something that's anomalous is to do experiments to try to find out what is making it occur. The first stage, which I'm satisfied has occurred, is in making it reproducible enough. It's still problems with that, but it's reproducible enough now so that we can be assured that it really is there, okay? The excess heat, the excess energy is there. The nuclear particles have been observed. These should not be occurring. Stage 2 will be when we study it in more detail and find out exactly how it's working. We don't know exactly how it is working now. It's a new process, just as superconductivity was in 1911, when it was accidentally discovered and was not explained for 50 years. The idea that electricity could flow through a metal at very low temperatures with zero resistance was unexplained for 50 years. And yet that didn't mean that it didn't exist just because we didn't understand it. Here, cold fusion exists, in my opinion, despite the establishment's intention to kill it, because they don't believe the experiments to begin with, but it's not explained. And yet there are some theories that begin to say it works roughly like this.
Help me understand what this really could mean for the average individual citizen. Say people in the less developed nations, for instance. What's the potential at the end of the long trail that seems to be in front of us?
If cold fusion is real, as I firmly believe it is, and is a power source, as I also firmly believe it is it has great potential for revolutionizing the world in a way that is so staggering that it is hard to even begin to imagine it. It will mean small power plants in houses to heat houses, perhaps to produce electricity in homes, the end of a grid of power lines perhaps, or central station power, but only from seawater or the ingredients that are therefrom. No more dependence on oil, no more dependence on fossil fuel, regardless of what one may think of the greenhouse question and the possibility of warming the Earth. If cold fusion could be applied, it will mean no significant pollution from any cold fusion power plant. That whole issue, the whole question of warming of the globe will disappear. It will dramatically decrease, it would seem to me, almost all political tensions that remain in the world, because it seems offhand that the power would be relatively cheap. It's dirt cheap to get heavy water, deuterium is part of heavy water, out of ocean water. $1,000 a gallon. But a gallon is so powerful that, it takes care of a lot of people.
But that's out in the future. That's quite a long way.
It's out in the future, but it may not be so far away. Now, this is an interesting question. We don't know what the time frame is for the development of cold fusion. Many skeptics listening to this program would probably say the man has stepped off the deep end. He actually believes that A, it's real, B, it will be used, and C, he's even suggesting that it might be sooner rather than later. Yes, I'll suggest that. I think cold fusion, if it can be controlled, understood, used, may be showing us useful devices within a decade, if not sooner.
Welcome back to this edition of Frontiers. And the frontier we're looking at this time is cold fusion. I'm John Parrott, and my guest is Dr. Eugene Mallove, author of the book Fire from Ice, based on the debate surrounding the scientific theory of cold fusion. Let's rejoin our conversation. Is there, or rather, are there any pollutants that would come from cold fusion?
Cold fusion, when it's finally understood, will probably have some types of pollutants, but they'll be very minimal. Its dominant effect in cold fusion is the release of energy in the form of heat. This is the extraordinary thing. There is tritium in some cases, but it's certainly not consistent in conventional hot fusion terms with the amount of energy that's being released. There's something marvelous about it, which allows nuclear energy release, and if it is a nuclear process, there have to be products that we will find in the system. But they appear not to be, even at these rather impressive levels that have already been developed of power, it appears not to be a big problem.
It sounds from what you've been saying that the international community is taking this whole question of cold fusion much more seriously than American scientists are, in the sense of its potential, in the sense of the fact that it could be there. Am I true? Is that right?
I think in Japan there's a much more open view of cold fusion. It's not necessarily accepted, although there have been some recent dramatic changes in that direction. But I think basically it's much more easygoing in places like Japan and Italy and the Soviet Union, for that matter. India did a lot of work. There are many countries that have done work on this. It is only, it seems, within the United States and England also, where there has been literally a witch hunt against cold fusion.
Aren't we in a way morally bound, though, to look closely at the possibilities of this for the very sake of survival?
I believe that's the case. I believe that to throw out a potentially fantastic new energy source, one that even the skeptics themselves maintain they can't explain. They say, oh, it might be a good battery or this, that, or the other thing. Explain it in conventional terms for me. If you can't explain it in conventional terms, there may be something even more remarkable there. It may be a new power source. They just wish it away. They say, we don't believe it, we're not going to look at it, and goodbye. Okay? Anti-scientific, in my opinion.
Eugene, in a way, you've taken us to the boundaries in one area with cold fusion. The possibilities, the potential is just almost perhaps beyond most of our imaginations. But what other boundaries are interesting you these days? You're not just focusing on cold fusion issues.
Well, I'm interested in all aspects of science, and the thing that interests me the most, I believe, apart from cold fusion, is the possibility that civilizations other than our own may populate the universe, and the galaxies in the universe, the other star systems, planets around other stars. I'm convinced they're there. I've been following the interesting developments over the years in the radio search for extraterrestrial civilizations. National Aeronautics and Space Administration, as well as private foundations and individuals, have been pursuing this, hoping to find a radio signal that represents intelligence out there. That's fascinating to me.
What do you define as intelligence, then?
Well, I believe that the universe comes to life. I wrote a book called The Quickening Universe, which says that, and this is not a new thought, but I synthesized it and said that the laws of nature, the laws of physics, embody molecular evolution, which then evolves into organisms inevitably, given a good planet. Not every planet can harbor life. But in the right conditions, I believe it's inevitable. And I also believe that this thing we call intelligence, which we embody, we believe, in animals also, but we are a more developed form of it, this also exists elsewhere and contemplates itself. That is, the universe contemplating itself.
My thanks to Eugene Mallove. Well, he certainly took us to the outer reaches of space and to the ocean behind me and that quarter-kilometer cube of ocean water and its potential power. Utopian dream or reality? I guess time will tell. Well, if you agree or disagree or would like us to explore a certain frontier, we'd love to hear from you. Here's the address: Frontiers, the Monitor Channel, 1 Norway Street, Boston, Massachusetts, 02115. Please write. Until next time, I'm John Parrott. Thank you for joining us on Frontiers. Meantime, take care. Goodbye now.